Ever tasted vinegar? It's tangy, sour, definitely an acid. Now picture a drop of concentrated hydrochloric acid falling on metal. It sizzles and smokes. Both are acids, but clearly they don't pack the same punch. So what makes one acid strong and another mild? And how do we measure the strength of an acid or a base? Is there a scale for that? Yes? In this video, we'll uncover how the pH scale, a simple number between 0 and 14, reveals the true strength behind every acid and base, from your kitchen to your chemistry lab. So how do we actually measure the strength of an acid or a base? Scientists use a special scale called the pH scale. The P comes from the German word Potenz, meaning power, and H stands for hydrogen ions. So yes, pH quite literally means the power of hydrogen. Here's how it works. The pH scale runs from 0 to 14. A pH of 7 is neutral, like pure water. A pH less than 7 indicates an acidic solution. The lower the number, the stronger the acid. A pH greater than 7 indicates a basic solution. The higher the number, the stronger the base. Let's look at some examples. Hydrochloric acid, a strong acid, has a pH around 1. Acetic acid, found in vinegar, is weaker, around 3 to 4. Sodium hydroxide, a strong base, is way up at 13 to 14. Milk of magnesia, used as an antacid, has a gentle pH around 10. From kitchen acids to cleaning bases, the pH scale tells their story in numbers. Now that we understand the pH scale, how do we actually test the pH of a solution? We use something called a universal indicator, a special blend of dyes that change color depending on the solution's pH. Here's how the colors decode pH levels. Red means a strong acid. pH between 0 and 2 orange to yellow means a weak acid. pH 3 to 6 green shows a neutral solution. pH 7 blue to purple indicates a base. pH 8 to 14 the darker the blue or purple, the stronger the base to use it. Just dip a pH paper strip, soaked in universal indicator, into your solution. Then compare the color with the pH chart to read its value. This simple tool is powerful, used by scientists, doctors, farmers, and even food technologists to test the pH of soil, water, blood, and food. We often talk about acids reacting with metals. But what about bases? Let's explore a lesser-known but fascinating reaction. Take a strong base like sodium hydroxide. Now add some zinc metal to it and gently heat the mixture. Guess what? You'll see bubbles again. Yes, hydrogen gas is being released. But here's what's different. The salt formed this time is called sodium zincate. The chemical equation looks like this. 2NaOH plus Zen Na2ZNO2 plus H2S. Spelled out, 2 molecules of sodium hydroxide plus zinc give sodium zincate and hydrogen gas. So what does this tell us? Bases, though usually gentle, can react with certain metals just like acids do. And yes, hydrogen gas is still produced in the process. Not all metals show this behavior, but those that do remind us, bases can pack a punch too. Let's look at another important chemical reaction. When acids meet carbonates. Take a spoonful of sodium carbonate and add a few drops of hydrochloric acid. Instantly, you'll see fizzing bubbles rise. That's carbon dioxide gas being released. Here's the reaction. Na2CO3 plus 2HCl, 2NaCl plus H2O plus CO2, spelled out, sodium carbonate plus hydrochloric acid produces sodium chloride, water, and carbon dioxide gas. Want to test for carbon dioxide? Just pass the gas through lime water. It turns milky white, confirming its presence. But this isn't just a lab trick. This very reaction is used in soda acid fire extinguishers. The carbon dioxide gas released smothers the flame by cutting off its oxygen supply. From classroom beakers to real-world safety, chemistry makes it all possible. So what happens when an acid meets a base? They don't clash. They neutralize each other. The result? A harmless combination of salt and water. This process is called a neutralization reaction. Let's take a classic example. NaOH plus HCl, NaCl plus H2O. Spelled out, sodium hydroxide plus hydrochloric acid produce sodium chloride, common table salt, and water. Simple but powerful. This reaction is the science behind antacids like milk of magnesia. When your stomach produces too much acid, the base in the antacid neutralizes it, bringing instant relief. So next time you reach for an antacid, remember, it's neutralization in action. Now, let's dig a little deeper into the world of oxides. Start with metallic oxides, like copper oxide, a black powder. When you add hydrochloric acid, a reaction takes place, forming salt and water. The equation? QO plus 2HCl. QCl2 plus H2O spelled out, copper oxide plus hydrochloric acid produces copper chloride and water. This behavior tells us something important. Metallic oxides are basic in nature. Now flip the situation, take carbon dioxide, a non-metallic oxide, and react it with a base like calcium hydroxide or lime water. What happens? CO2 plus CaOH2, KCO3 plus H2O. That is, carbon dioxide plus calcium hydroxide gives calcium carbonate and water. This reaction shows that non-metallic oxides are acidic. They react with bases just like acids do. So here's the takeaway. The type of oxide, metallic or non-metallic, gives us a strong clue about whether the element is basic or acidic in nature. Let's take a quick recap of what we've explored. Acids react with metals to release hydrogen gas and form salt. Bases, though less commonly, do the same with some metals. Acids plus metal carbonates produce salt, water, and carbon dioxide. Acids plus bases, they neutralize each other to form salt and water. Metallic oxides behave like bases. Non-metallic oxides behave like acids. But here's the real magic. This chemistry isn't just confined to labs. It's happening all around you. Got acidity? Antacids like milk of magnesia use bases to neutralize stomach acid. Fire emergency? Soda acid fire extinguishers release carbon dioxide to put out flames. Curious at home? Turmeric and red cabbage make excellent natural indicators. Tooth care? Toothpaste helps fight acid in your mouth. A perfect example of neutralization. So next time you clean with soap, taste a lemon, or feel that bee sting, remember, acid-base chemistry is quietly at work. In the next video, we'll dive deeper into the secret behind all acids and bases, what they truly have in common, and why water holds the key to unlocking their behavior.